Hi, this instructional video is about Pythagorean Theorem. How to use the Pythagorean Theorem to find the missing side of a right triangle. Before we get started on this one, there are some things we need to understand. Here we know that this is a right triangle indicated by this little notch over here, 90-degree angle. And so this is the right triangle. In this right triangle, it is separated by two legs. Either you could call this A or a B. It really does not matter when we use the Pythagorean Theorem, as long as you distinguish the longest being the hypotenuse. 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 It is the longest part of the right triangle. So number one, we are looking for the hypotenuse, the measurement. The legs A and B are given as 8 and 15. And the Pythagorean Theorem is defined as a squared plus b squared equals c squared. And so let me demonstrate how to solve for the missing side for number one, and you could try the following examples. In this case, once again, we're going to indicate that this is the leg A and this is the B. So we're looking for the hypotenuse. So we go a squared plus b squared equals c squared. A, we defined it as being 8. So we're going to substitute the a with an 8. Plus the b is the 15. And that equals what we do not know, the c, the hypotenuse. So when we evaluate 8 squared, that's 8 times 8 or 64. 15 times 15 is 225. And when we add it, we're going to solve for the square. So 64 plus 225 is 289. And that's going to equal c squared. And to solve for c, we're going to do the inverse of a square, which is in fact square root. And if you square root one side of the equation, you better square root the other side as well. Hence the definition of equation. To evaluate the square root of an exponent 2 here, it means that c times c, so c is the square root of a c squared. And here, 289, well, we're going to take a wild stab at it. Let's see. 289, well, think of it this way. 8 times 8 is 64. The longer part is 15 times 15, which is 225. So the longest part must be more than 15. So what same number, if you multiply this off, will give you the last number 9? I'm going to guess maybe 17 times 17. So let's try that. What is 17 times 17? That's 49. Carry the 4. 7 times 1 is 7 plus the 4 is 11. And the identity 1 times 17 is 17. And if you add that, does that give me 289? Oh yeah. So the square root of 289 is in fact 17. So the missing side, the hypotenuse, is 17. Now why don't you try? When you work with students in math, you need a lot of these. Why don't you try numbers 2 and 3? Okay, now number 2, you said, all right, here's the A, here's the B. We're looking for the missing side C. So we're going to use the Pythagorean Theorem, a squared plus b squared equals c squared. Since this is the A, we're going to substitute it for this A here, so that's 7 squared. And that's the B, so that's going to be 24 squared. It's a huge number, and C is what we don't know, so we're going to solve for that in a minute. So 7 squared is 49, plus 24 times 24. Let's see, 24 and 24. That's 16, carry the 1. 8 plus the 1 is 9. Double the 24, so that's going to be 48. Add them together, I get 576. So 576, and whatever you add, you're going to square root it. So 576 plus 49 is going to be 5 Carry the 1 over to the 7, 8, and 2, and 625. And that's c squared. Now to solve for c, we're going to square root both sides of the equation. Square root of a c squared is c, because c times c is c squared. Now what times what is 625? Well, here's a hint again. The shortest side was 7. The longer side was 24. The longest side, the hypotenuse, must be bigger than 24. And what same number, if you multiply, will give you the last digit 5? I'm guessing 25. So let's check. 25 times 25. 5 times 5 is 25. Carry the 2. 2 times 5 is 10. Plus the 2 is 12. Double the 25 is 50. Add that up. What do you know? 625. So square root of 625 is in fact 25, because 25 times 25 would give you the radicand 625, and that is the missing cipher number 2. And finally, number 3. Once again, the shortest leg is 3, longer one is 7. The longest side, which is always the opposite of the vertex here, okay, is the hypotenuse. So if you like, you could call this A, and you could call this B. So we're looking for the C. So once again, a squared plus b squared equals c squared. A squared, we are calling it 3, so that's 3 squared, plus b is now 7 squared. We're going to look for the c squared. So 3 squared is 9, 7 squared is 49, equals c squared. Add them two, I get 58. Oh, this one does not come out nice, because 58 is not a perfect square. Anyway, let's go ahead and solve it. So you square root both sides. Square root of a c squared is c. What on earth is 58? Well, here we go. Let's estimate. Shortest side is 3. Longer side is 7. The longest side must be something more than a 7. So let's see. I know that 7 times 7 is 49, and 8 times 8 is 64, so 58 is somewhere in between. So what if I say, let's see, 7.5. So let's check it. 7.5 times 7.5, that's 25. 35, bring the 2's 37, that's 35. 7 and 7 is 49, bring the 3 is 52. That's 5, 2, 6, 5, 2 decimal places, 56.25. We're almost to 58, but not quite. How about if we say 7.6 times 7.6? That's going to be 36. 42 plus the 3 is 45. 42. 7 and 7 is 49, plus the 4 is 53. And now I add that 6, 7, 7, 5, 2 decimal places. 5776 is closest to 58. So approximately it's going to be it's going to be approximately 7.6, because 7.6 times another 7.6 almost gives me 58. So sometimes you have to do that. And then why don't you try numbers 4, 5, and 6? While I take some of these. All right. So how did that work out, huh? Well, let's bring this back to remind us what a Pythagorean theorem is supposed to be looking like. The general form is a squared plus b squared equals a c squared, keeping in mind that the longest part is called the hypotenuse and represented by the letter c. So if you compare that with number 4 here, you'll realize, hey, okay, I see an A, or the side dimension, but I don't see down here. But the longest part, which is opposite of the vertex here, is the hypotenuse. So this time the C is given. So we're going to look for the missing side, B in this case, by using the same standard form of a squared plus b squared equals c squared, the general form that is. So if you like, you could call this the A, The b is what we do not know, and call this the c. This time the hypotenuse is given. So we're going to substitute the a with the given 5. So 5 squared plus b is not given. We're looking for that. And c is the 13 squared. 5 squared is, of course, 25 plus the b squared, which we do not know. And 13 squared, I just memorized it as 169. Now, if you recall from our past instructional videos, we're going to use algebra to solve for the missing part b. So we're going to use subtraction property of equality. Move that 25 over by subtracting it both sides. It's the opposite of positive 25. So on the left side, the 25 and the negative 25, it's a zero product property. They're gone. So we have b squared on the left side. On the right side, 169 minus 25 is 144. Look at that. 144, as you know, is a perfect square number. So if you square root both sides of the equation, the square root of a b squared, since this is like saying b times b, the square root of it is a b. And you know that square root of 144 is 12, because 12 times 12 is 144. So the missing side here, the b, is 12. And it makes sense. 5 is the short part, 12 is the longer part of the leg, and the longest part is 13. All right then. How about number 5, huh? So number 5, this time the vertical portion of the triangle is not given. So we could still call that A, so we're looking for that. The B is now given as 45, and the C, the longest part opposite of the vertex, the hypotenuse is given as 53. So we're going to still use the general form, a squared plus b squared equals c squared. A squared this time is not given, so we're going to look for that. B is 45. But keep in mind once again, it doesn't matter whether you put this A or this B. The only really important part is always make sure to identify the C, the hypotenuse, correctly. It's going to be on the right side of the equation. C is 53 squared. So let's evaluate. 45 times 45. 45 times 45, because it's 45 squared, is 25. Carry the 2. That's 20 plus a 2 is 22. 4 times 5 is 20. 4 times 4 is 16. Plus a 2 is 18. Add it down. 5, 2, 0, 2. Okay? So that's a squared plus 2025, which equals on the right side, 53 times 53, since it's 53 squared, is 3 times 3 is 9. That's a 3, okay? Ooh. And 3 times 5 is 15. 5 times 3 is 15. 5 times 5 is 25. Plus the 1 carried is 26. Take the sum of the two products. So 9, 0. That's a 2 with an 8 and 2. So that's going to be 2809. Now we're going to solve for A by subtracting 20, 25 to both sides of the equations. Thank goodness. So the 2025 minus 2025 is an additive inverse. They're opposite, so they 0. So we have a squared on the left side of the equation. 2809 minus 2025 is simply, well, not simply, but 9 minus 5 is 4. No can do, so 8. Reduce that by 7, 84. So what's the square root of a squared? Well, it's a. What's the square root of 784? Here's a hint. Here's 45. The shorter part, I don't know. 53, it's got to be shorter than 45. So what times what will give me the last digit of 4? 7 maybe? And not 47. How about 37? So 37 times 37, let's verify. 7 and 7 is 49. Whoops, wait a minute, why 37? What times what is 4? How about 38? Because 8 times 8 is 64. So here's 64. 3 times 8 is 24, plus a 6 is 300. Or 30, I mean. 3 times 8 is 24. 3 times 3 is 9, plus the 2 is 11. That's 1444. That's way too much. How about 28 then? 28 times 28. 8 and 8 is 64. 2 times 8 is 16 plus the 6 is 22. Double the 28 is 56. 487. 487? There it is. So it's 28 times 28. That gives you 784. So square root of 784 is 28. The missing side is 28. Okay. So how did number 6 turn out for you? You're probably thinking, what is that? Is that a triangle? Yeah, it's a triangle. Sorry. So anyway, you could tell this somewhat of a hypotenuse because it's opposite of the vertex, okay, is denoted by the letter C. We're looking for that now, okay? Now, this one is pretty close, but if you want to keep it consistent and say this vertical dimension is the A, it's totally up to you, as long as you got the C correctly. And this will be a B in this case. So we got A squared plus B squared is equal to C squared. A is 15 squared. B is 20 squared. And C, as imperfect as is, still the hypotenuse, and we're looking for that. So we evaluate. 15 times 15 is 225. I just happen to memorize that. 20 times 20 is 4 with 2 zeros. And that equals a C squared. 225 plus 400 is 625 equals C squared. And if you square root both sides of the equation, well, square root of a C squared is a C. Now here's a hint again. That's a 15. The longer part is 20. So the longest part must be more than 20. And what two numbers, identical if you multiplied, would give you a last number of 5? Has to be bigger than 20. So I'm guessing 25 times another 25 might give me 625. Let's check. 5 times 5 is 25. Carry the 2. 2 times 5 is 10. Plus a 2 is 12. Double the 25 is 50. And voila. There it is. 25 times 25 times 25 is in fact 625. So square root of 625 is 25. And that makes sense. The longest part of this triangle, the hypotenuse. There you have it.